Hello everyone. Our topic for the DA of data structures and algorithms was sorting techniques. So, what are sorting techniques exactly? So, any sorting algorithm is basically used to arrange elements of an array or a list in a specific order, such as in ascending order or descending order. This can be done using various different sorting algorithms such as bubble sort, selection sort, insertion sort, merge sort, quick sort, etc. Each of these have their separate working and in the end they produce the same output. However, we can decide which particular sorting algorithm to implement in a certain place depending upon how much space we have available to allot to that algorithm and how much time we can allot to that particular algorithm to actually make it function efficiently. So the first algorithm that we're going to be dealing with is bubble sort. Bubble sort basically works by repeatedly swapping the adjacent elements if they are in the wrong order. So wrong order can mean anything. If we want an ascending order, then the wrong order would be a bigger element coming before a smaller element. Now this algorithm is actually not suitable for large data sets as its average and worst time complexity is pretty high. So we need to choose it properly. So let us consider an example for bubble sort. Here we have an array which is 7, 3, 6, 2, and 9. So we will very first deal with the first two elements. So in this case we see that 7 is the first element and 3 is the second element. Now 7 is greater than 3, and if we want the array to be sorted in an ascending order, then we will want to swap 3 and 7. This will continue until the end of the array, and then we will loop over the entire array several times in order to get an entirely sorted array. We also have the algorithm of bubble sort written right here. So we declare a function named bubble sort in which we pass the array that is needed to be sorted. Then inside this function we declare a nested for loop. And inside the for loop we are basically just checking whether the next element is greater than or less than the previous one. If found to be less than the previous element, then we create a temporary variable and we swap the two elements. And this continues until the end of the loop. We will also consider the time complexity of bubble sort as a major factor when it comes to deciding which particular sorting algorithm to use. So for bubble sort, the worst and average case time complexity is O of n square because we have a nested for loop. This basically occurs when an array is sorted in reverse order. Now the best case time complexity is O of n, and this occurs when an array is completely sorted in the first place. The space complexity of bubble sort is O of 1. The third sorting technique is insertion sort. So in insertion sort, basically we split up the given array into a sorted and unsorted part. However, this is done virtually. Next, values from the unsorted part are basically picked and then they are placed at the correct position. So this is done using repetitive comparisons. So let us understand this better with the help of an example. We are given an array which is 3, 7, 9, 6, 2. And in this, the first three elements, 3, 7, and 9, are in sorted order, or we consider it to be a sorted subarray, and then 6 and 2 are considered as unsorted. So when we reach 6, basically we will compare 6 to the previous element. Now we can see that 6 is less than 9. So we will go ahead and compare it with the element before 9 as well. So here again 7 is greater than 6. So we go another step behind and compare it with 3. Now 6 is greater than 3. So what we do is insert 6 in between 3 and 7. Hence, the sorting algorithm is called insertion sort. Given towards the right again is the algorithm. So we are declaring a function called insertion sort and passing the unsorted array into that function. Then we declare a particular variable which is called key. Now what we do is we assign the second element, that is, in this case it is 7, we will assign it to the key. And then we declare a particular integer j which is I minus 1. So in this case it would be 0. So that is j would be 0, and if we take ARR of j, that would be 3. So we say that while j is greater than or equal to 0 and the array element, that is in this case 3, is greater than the key, which is in this case 7. In this case this condition is not satisfied, so the loop will not execute itself, but whenever this condition is satisfied, we go inside the particular loop and then carry out insertion sort. The time complexity of insertion sort is again O of n squared due to a nested for loop or a while loop, whatever is suitable, and the space complexity is O of 1. Merge sort algorithm is slightly different from the algorithms that we have seen previously because it basically works on a certain technique called divide and conquer. So in this algorithm, what we do is divide up the array into equal parts until we have small arrays with only one element in each array. After this, we compare the elements in these small arrays and then merge them again. So basically, we split up the entire array, compare, and then merge it again in order to get the sorted array. So let's consider an example. Given here is an array which is 9, 7, 3, 6, and 2. And then we are going to split it up. So we split it up first into an array of 3 and 2 size, and then we split it up further into 2 and 1, 1 and 1, and then here also 1 and 1. Now we will basically compare the small subarrays consisting of only one element each, and then whichever is the smaller one out of the two will be placed first, and so on we go on merging these subarrays to form the entire array in a sorted fashion. So given to the right is the algorithm for merge sort. Basically we have a function called merge sort in which we pass the array as well as the left index and the right index. Now we will check a condition whether left index is less than the right index or not. If it is that way, we find the midpoint using the given formula, and then we recursively call merge sort. However, when passing parameters, we pass the array and then we pass L and M in this case, which is the midpoint. So this recursive call basically divides up the entire function, the entire array, and then we call the function merge. So merge has an algorithm in itself which will merge these small elements into the bigger array. The time complexity of merge sort can be given by solving the given recurrence relation, that is T of n equal to 2t n by 2 plus O of n. So if we solve this, we will basically get O of n log n, which is the time complexity of merge sort, and the space complexity is O of n. Quicksort is again a divide and conquer kind of algorithm. So, in order to sort the given array, quicksort basically picks a particular element as pivot element, and then it partitions the given array around that picked pivot. So, this will be partitioned into left array, pivot, and then we have the right array. So, the working of quicksort is given in the next slide. Let's understand quicksort better with the help of an example. So here we have an array which is 7, 9, 3, 2, and 6. If we consider the pivot element to be 6, then after applying quicksort, basically we find out the exact position of the pivot element, which in this case is 6. So now we have the position of 6 as fixed. So the elements which are towards the left of 6 would be the unsorted array, which comprises of 3 and 2, and the elements to the right of 6, 9, and 7 comprises the right array. So we split it up and then we apply quicksort on these two sub-arrays and so on. After applying this entire procedure, we will get the entire sorted array, which is again merged. So towards the right, we have the algorithm of quicksort. Basically, we just have to define a function named quicksort, pass the unsorted array into it, and we also pass the starting index and ending index. So if S is less than E, then we can execute this particular code, which just kind of recursively calls quicksort and sorts the entire array in order to get a proper sorted array. Now the time complexity of quicksort is, in an average case scenario, it would be O of n log n. In worst case scenario, it goes into O of n square, and the space complexity is O of log n. So the average case is also the best case scenario of quicksort. This occurs when we select the pivot element as mean element. Like the mean element is the pivot element, that's when we will have best case time complexity. As for worst case scenario, this happens when the array is actually already sorted and we select the smallest or the largest indexed element as pivot. That's when we will have our worst case time complexity, which is O of n square. So that was the explanation of all the different sorting techniques used to sort any given array. Thank you. The next sorting algorithm is selection sort, which basically sorts an array by repeatedly finding the least or minimum element in the array, considering that we are sorting it in ascending order. And then from the unsorted part, it just puts that minimum element at the beginning of the array. So for example, if we have a particular array, say 11, 12, 25, 22, and 64, if we consider that the first two elements are already sorted, then in the unsorted subarray, we have the order 25, 22, and 64. So here we will find the minimum element, which in this case is 22. And then we will put it at the beginning of the unsorted array. So we will basically just swap 22 and 25, and then we will still consider 25 and 64 as unsorted, and after verifying that 25 is less than 64, we will call the entire array as a sorted array. Given towards the right is the algorithm of selection sort. So again, we declare a function named selection sort and pass the array to be sorted into that function. After this, we declare a nested for loop. So in the first for loop, first we will declare the first element as minimum, and then this goes on incrementing. Inside the second for loop, we are checking whether the array element is greater than or less than the declared minimum. If it is not the case, then we move on. If, however, the minimum element is greater than the element in the array, then we need to change the minimum element, which is the condition given in the in the if statement, in which we are also creating a temporary variable in order to kind of swap places. So the time complexity of selection sort is again O of n square, since there are two this nested for loops basically, and the space complexity of selection sort is O of 1.